What's up, guys? Welcome back to Arta Interprets. Today I got two videos for you, and this is the second of those two videos. So unless you just watched the last video, you're a goat with the cubes, or you don't give a shit, I'd go watch that one first, because in this one, we're talking about the code, how to code a 4D cube. It's gonna look something like this if you code it. Let me open up my display capture. And nope, that's the wrong window. It's in C. Like I boot up like the terminal. I open up command prompt, and then I do this bitch in C. And this is what it would look like if you do it. And this is what we're talking about in this video. So if this interests you at all, uh, watch the video. And if it doesn't interest you, don't watch the video. All right. Uh, let's get into it. Alright, so let's get into it. This was coded in C, which means it's very low level. About as low level as you can get without like just doing it in like assembly robot code. So this is not something in Python where I can just call a function to do whatever I want for me. Oh, call draw 3D cube function and it just does the whole thing. No, this is basically done with like for loops and if statements. That's literally it. The most complicated thing I used were pointers. So I have this split up in three files. I have like a header file with all my imports. I have a main file that does all the top level stuff, and I have a functions file that does the low level stuff. Uh, and I have it organized into three main functions. So if you go up here, I have my includes. I have this graphics library here, which is actually, I think, just created by my professors to like kind of streamline, because they wanted to teach us graphics, but they didn't. This isn't like a super low level course. It's fundamentals of C. So they gave us this library, and all it can do is it can open graphics windows, it can draw points on a screen, it can draw lines, it can draw circles, and it can change colors. And that's it. Everything else was done by me. And then I have the main C library, math library, and this one for the animation, like the sleep function. So I started this by making two data structures, one for the 3D cube, one for the 4D cube, and I used a struct as that's the only data structure in C, and this is just basically like a folder of different values, kind of, so I can store my vertex points as like a 2D array, so all 8 of my all 8 of my vertices and all 3 of the XYZ coordinate positions, and then I can store the number of vertices and the dimension, and do it for both. And these structs get populated down here. I have all the 8 vertices for the 3D cube, 8 and 3, and then all 16 here, 16 and 4. And then I create 2 cubes and set them equal to each other, and I'll explain why later. And then I have stuff for the screen, that's whatever. I open my window and I start the main while loop. So to do animation in this, I have one while loop that loops through everything, and then I sleep, I think this is like 0.02 seconds or something, so it's not like super fast, because the computer is pretty fast at doing this. And then I have a couple buttons. You can start the animation, you can reset the animation, and you can quit the animation. I have an FOV for the camera, which I'll explain later, and I have like a length value to make the cube bigger. And then the main bit of the code is in these two functions. I have a draw function and a rotate function for both of the cubes, and they have a lot of arguments. I send like the vertices, I send the FOV, I send the length of the cube, the center position of the screen, the number of vertices, and the dimension. And then I do that for the 4D cube too, and then to rotate I send the cube vertices of both of these cubes, which I'll explain why later, a theta value, t, for the angle I'm rotating about, and then a number of vertices and the dimension. And I did this only in 3 functions because I wanted to try and keep it like this this rotate, and I guess all three of them to work in any n dimension. I'll talk about this more later, but in theory, I think it would be possible to recursively create something in C to generate any n-dimensional cube, and I think that's pretty cool. So, to do this, instead of using arrays, which in C, like, statically store values, like when I'm declaring these arrays, I have to put values here, and I can't change how big this array is. So this can only hold 8 vertices and only hold 3 points. And this can only hold 16 vertices and 4 points. And when I do these functions, if I were to send these array values directly to them, I would have to have two different functions because C can't tell the difference between an array with 3 values and an array with 4. So if I make functions with the 3 array, they would not work for the 4 array. To get around that, I used pointers, which instead of dealing with the values themselves, deal with the locations of the values in memory. So instead of sending the values, I send an address of the values. That's what I'm doing with this double star down here. I'm typecasting these arrays into pointers, since they're kind of treated a little similarly, and I send the address of the first element of the array, and then I deal with that element dim number of times. So let's get down here to the draw function. So I take in all of these values over here, and I set up arrays to store positions of all the points. And I have a for loop that uses vert here, which changes depending on the vert I sent in over here. And I have this very long projection formula, and I'll show you how I derived that now.
Alright guys, a little intermission to show you how I did the projection math. So you kind of have a cube here in XYZ space, alright? And that just has all the vertex positions, whatever. You can project that cube onto the YZ plane or onto the XZ plane, which means like, just pushing it in. So you end up with like a square here. And you can set up an FOV, which I used theta there, you can see, and draw like some vectors out from like theta over 2 in either direction, and that'll create you like this is where like the screen would be versus like this is where the cube actually lives. So you can create right triangles between the origin, each of the vertex points on the cube, and where those vertexes lie on the screen. So I guess it's kind of hard to see because my drawing isn't that good, but it turns out something like this, where this is half the screen right here, this line right there. This is theta over 2. This is where the point actually lies, and this is the z-axis. So yeah, this is the point you want to calculate. This is the one you have. And you have this one. And this is just a variable. So then you can use trig. Tangent of this theta over 2 is opposite, which is 1, over adjacent, which is n. You can solve for n. And then you can use a proportion. Since this triangle is proportional to the bigger triangle, you can set these two equal to each other. And then you can solve for the one you want. And then you can substitute n back into here and do some algebra and arrive at this formula. And you can do the same thing about x. And then rotations, a little bit about rotations. This is the 2D rotation matrix that'll take you like this way, counterclockwise along the XY axis. And I talk a little bit more about how this works in higher dimensions in the video. And here I have like the big matrix that I ended up not using with like the yaw, pitch, and roll. I also talk about this later. Cool, doesn't matter. And then for 4D, I had like a similar kind of a projection. I was like, okay, so if you can project it from XYZ to like YZ or XZ, why couldn't you just like do it again? So that's what I did. So I have a point, I have a XYZW, and then I project that onto YZW and XZW, and then I do all that math, and then I just do that math again for XZ and YZ, and it actually worked first try. It blew my mind. I had no idea that was gonna work, and then it did. And then for some of the vertex math, no, the edge math to like figure out how to connect the edges, I like drew out my cubes on paper and then like colored the vertex circles differently to try and figure out like what their numbers were in memory and then draw the lines between them. I talk about that a little bit later. Cool, back to the video.
Alright, welcome back. That was a lot of math, but now you kind of understand a little bit of what's going on here. So, I have... Alright, so I have these two arrays of the size of the number of vertices based on the cube I'm passing in, and then I loop through all of the positions, okay, and I pass through this formula with two critical changes. So first, I multiply the whole thing by a length value, so it's not absolutely tiny, because I'm dealing with like 0.5 over here. And then I dereference the position I sent with the pointer of this position, and then I add whatever loop indice it's on to like do all 8 of or all 16 of the vertices, multiply it by the dimension to like loop through the second dimension of this array over here in the cube, and then I add a 0 or I add a 1 depending on if it's x or y. And all of that is the top part of that fraction in that formula you just saw. And the bottom part of the fraction is that same kind of pointer dereferencing math over here. And then I add a 2 to access the z element of that. And then I have another 2. This is a critical 2, okay? And this like took me the longest time to figure out what was going on. And I'll show you what happens if I get rid of this 2. And I have that times the tangent of half of the FOV and then the entire thing plus the center and the X center and the Y center to kind of position these points in the correct spot. So what this 2 does here, which I didn't know originally, my camera is not set up how it is shown in that picture you just saw. So what this 2 does is it pushes back the cube. I was doing this for the longest time with this because I was thinking, oh, my projection math makes sense. The cube is in front of me. Why isn't this working? Oh, wait, I have to get rid of both of them. There's another one down here. Boom. No, no. Why isn't it working? Why are all my lines like this? It was driving me crazy. It made no sense. Especially the 3D one. Let me comment out the 4D one for a second. Boom. Because it's kind of like moving around. I'm like, this kind of looks like a tangent behavior. Like, why is it kind of going off into infinity? This makes no sense. Why am I only seeing one face? Because I thought all my math was correct. And it turns out everything was correct except I was inside of the cube. I was drawing the cube around me. So that's why when it rotated around in space, it was going off into infinity because the different faces were like moving around my head. I was in the center of the cube since I was using plus and minus values over here. So what this 2 does is it pushes back the cube away from you. So you're no longer inside of the cube. And it has to be outside of this parenthesis here. It's the same thing going on, except now it's you're away from it, whereas before I was inside of it. Moving on. So that's the first projection, and if dimension is 3, then I just print, and I'm done, and I move on. If dimension is 4, I do that same math again, except I add a 3 over here to access the W element of the pointer, and Then I do the same thing, and I draw those points. And then I draw the lines between all the vertices of the cube based on that picture you saw, and I color them differently before each one. Here you have 12 edges. Here you have 32 edges. These are kind of hard to figure out, but it's just lines. Like this is the library function for lines between two x values and two y values. Simple stuff. All right. So then at that point you get this. Cool. And once you get this, you know it drew and you know it worked. But then you want to rotate it because you don't actually get the animation if it's just sitting there. And to rotate it, I use rotation matrices. As you saw in that video, at first I was trying to make this huge rotation matrix do everything in one go, but that was just not clean code, and it kind of limited what I was able to do. So instead, I made a bunch of small rotation matrices and multiplied them together. So I took the 2D rotation matrix and inserted it into different positions of the larger matrix, so it only modified certain values and kept other ones the same. I have identity matrices down here, which are like basically just ones in higher dimension. So this is like a transformation that changes nothing. So I keep the ones in the positions that I don't want to change, and then I change the other ones. So for x, y, z, I keep x, y, and z the same, and then I change the other values. And for the cube, this was easy. All I need is 3 because it rotates about edges. But about for the 40 cube, they rotate about planes, so I need 6 of them. So instead of something that rotates about the x-axis, the y-axis, the z-axis, I need something that rotates about the xy plane, the yz plane, the xz plane, the xw plane, the yw plane, and the zw plane. In that first recording, I actually noticed this might be wrong. This might be actually labeled wrong, because over here for the XYZ, I keep X, Y, and Z the same. But over here, when I say this is like an XY rotation matrix, I modify XY and I keep ZW the same. The rotation should look the same, like the math is fine, but I think these are just labeled differently. Maybe I'll go in and figure that out. But anyway, once I get these, then I go up here and I multiply them together. This is where that temporary value comes in, the thing I was talking about earlier, where I create 2 cubes and I assign one to the other. Because in C, you don't have all the flexibility like you have in Python, where you can be like, oh, swap these 2 values, and it'll do everything for you. In C, if you take one value and you put it into another one, then you lose the original value. So you need to create a temporary variable or a temporary data structure for whatever you're doing, and then you have to copy over everything into the temporary value, and then assign that to the thing you want to swap with, and then assign the temporary value back to the original thing. So you need kind of like an intermittent step. So that's what I'm doing here. Same pointer math, because I'm not using arrays, because this can be done with any n by n matrix. And then I'm multiplying it together. If you know how matrix multiplication works, cool, this should make sense. If not, don't worry about it. I'm just multiplying sort of these functions together to make like a superposed transformation. And then over here, I start rotating. So for the 3D one, I rotate about all 3 axes. I multiply the identity matrix by all 3 of these. So I generate like a huge matrix with all of the rotation, and then I multiply all 8 of my, or all 4 of my, all 8 or all 16 of my vertex positions by that matrix I generated over here. And for the 40 cube, I actually only rotated about 3 planes, because I found if you rotated about more than 3 planes, you kind of lose meaning in like what's going on, because there's just too much rotation. You can't really tell what's going on. I'll show you what that looks like in a second. So the one cool thing about this, you can mess around what axes it's rotating about. So let me show you what this looks like if I comment out. So it's only about the z-axis and only about the zw plane. let me show you what that looks like. So what this means is when the 3D cube is rotating about the z-axis is the one pointing directly at you, so it's kind of going counterclockwise around that axis. And this one, since it's rotating about the w-axis, the first 3D projection is morphing, so you see this kind of morphing action going on, and there's no 2D rotation kind of like this one, because the z-axis is pointing at you, so it's rotating about a plane that's kind of out of 2D view, so it's just doing this kind of morphing motion. And I also figured out, I didn't know this, the Tesseract only morphs when it's rotating about a plane containing a complex axis, like the W axis. So that's why I only have it rotating about XW, YW, and ZW, because those are the planes containing the W axis, and that make it morph. If I were to comment all of those out, and have it so it only rotated about the XY, the YZ, and the XZ planes, the 3D motion and the 4D motion will look very similar. Even though this cube is stored in 4D space, since it's only rotating about planes visible in 3D view, it looks like it's just acting like a normal 3D object. Because this projection is the same from 4D to 3D, and then you're only acting in 3D space. So these two actually look very similar here. And then if I comment out, let's just show you what this looks like in Y. Let's get ZW and YW here. You get something like this, where this one now is rotating about the axis, the vertical axis here, since that's Y, and it's just rotating around that counterclockwise, and this one is kind of different. You don't see a rotation like this when you look up Tesseract on Wikipedia or YouTube, which is kind of cool, because this one doesn't make the most sense. The ones they post on YouTube or the GIFs or whatever are the ones that, you know, make the most sense, the most optimal rotations, but then you never really see stuff like this. When you can choose what planes you rotate about, you kind of get a new understanding for what's going on here. Since it's still modifying the W axis, then you still get that morphing action, but now it's kind of going up because you're dealing with Y and Z as well. And there's a bunch of cool different kind of rotations you can get by having this freedom of rotating about everything. So yeah, let me show you what it looks like with all of the planes. It looks like this. And in my opinion, this is too much rotation. You kind of lose meaning, so I didn't keep it like this when I submitted it for my project. But it's cool to see. This is all the rotation at the same time. Wait, we don't get everything in for the 3D cube. Let's play for a little bit. Shoot. Boom. This is everything. So you get all 6 planes, all 3 axes, and there's just a lot going on. It's pretty cool, but it doesn't make that much sense. So I think the Tesseract animation that has the most meaning is the one rotating only about complex planes. And that's about it. You've seen it all. I store the points in a data structure. I project them from 3 or 4D space onto a camera. I draw lines between all the vertices, creating edges, and then I rotate them by multiplying them by rotation matrices about whatever axis or whatever plane you want, and then I update a theta value to make this actually animate. I have it looping forever until you press Q, and I have this theta which loops pi over 128 every 0.02 seconds, I believe, to make sort of like a smooth animation. And if I press space, it just resets the theta at 0, which resets it to the cube looking like this. So I can do that, and then boom, it's back. And I can also click any button to pause it at any point in time in the rotation. And yeah, if I wanted to make this recursive to work for any n dimensions, I would have to figure out an algorithm to generate these points for every plus or minus x, y, z to any n values. I have to figure out how to way to get this inside of a data structure, which I don't really know how to do, but I think it should be possible. And then also, I'd have to figure out how to generate these rotation matrices for of any size, which again should be possible, but I don't think I really know how. So if I figure that out, I'll give an update. But if not, all the rest of the math works, like all the drawing stuff and all of the rotation stuff, except just this data of like where the points originally are and how they will rotate, is done with pointers, which means it can be done for any amount of values since I'm just dealing with addresses. So that should be possible. It would be cool. Maybe I'll look into it. And yeah, that was it. Alright, yeah, that was about it. Thank you so much for watching. I really enjoyed doing all this thinking about the cube because there's no real purpose and it's impossible to think about it. So it's kind of a brain twister. Uh, this guy, I want you to check out this guy because if you think this was cool, there's something just way cooler. This guy, Code Parade, okay? He created a golf game in 4D and it's like it's actually 4D, like it's just lore accurate. He has a YouTube channel with dev vlogs and shit. I just found out about this and I'm playing it with Cole, and it's just like the coolest thing ever. Like it's such a goated idea. Like there's no other game that would be fun in 4D but golf. Golf is just the greatest game to do it, and he did a great job. And I think you should check that out if you enjoy this kind of stuff. And it's all I kind of want to make a 4D game now. So if anybody can think of any other game ideas that do that, I want to try. I don't know. I'm kind of thinking because like any game like Doom or like a shooter would just be like harder in 4D and just not be fun. Like I don't know because you just get shot from the fourth dimension and then you wouldn't know where it's going. You wouldn't know where to aim because golf is good because it's kind of turn-based, so you can kind of line yourself up in 4D every time. I don't know. I'll think about it, and if I get anywhere, I'll make an update. But until then, thank you for watching. Go watch the other video if you didn't watch, and I will see you. Goodbye.